I've got Trey Smith. Welcome to Radio Eden. And today our subject is evolution. Trey, you've done some work on evolution. Tell me what do you think? Is evolution true?
Well, according to Occam's razor, on one hand of the fence, you've got the arguments of evolution that in the beginning there was nothing. Nothing exploded and became sheer precision everything. The rocks began spitting out digital coding that we today call DNA.
Yeah.
And the dogs became whales, the monkeys became people, and some would argue in what's called multi-universe theory that it's actually Elvis on the other side of reality.
Yeah.
No. I don't believe in evolution, and I can take you through some practical reasons why I don't. Because it's less of giving an opinion on the subject than because I don't want you to take my opinion.
Okay. Trey, maybe quickly, just tell me what evolutionists believe. So maybe for our listeners to sum it up in a few sentences. So the concept. Okay, go ahead.
Evolution proposes, in 1859, Charles Darwin wrote what's called The Origin of Species. And this proposes that life originated from random accidents.
Mm-hmm.
So, and bear that in mind, because a lot of evolutionists don't put that in perspective, that what you're really talking about for all of these increase in changes to occur, these have to be random accidents, no guided hand whatsoever, that somehow become life, and that life improves over time in complexity, leading to right now today, while we're sitting on this radio show talking to the folks out there. So that's what evolution states. Basically, there is no God, and it is one cosmic accident. All of this is a product of sheer, absolute, magical accident.
And obviously, it's very hard to believe. Evolutionists say they tend to put a lot of time to explain those accidents. So they say, "Oh, it won't happen in one generation, but it's like a million generations to get this." And then I think there's this concept of survival of the fittest.
There's some fun. Well, survival of the fittest is real. The survival of the fittest is one of the things that hurts evolution. For example, if you've got bald dogs and you've got hairy dogs, and a snowstorm comes through, you could easily lose your bald dog. So you started with two different kinds of dogs. So you began with two types of dogs. The environment changed, right? And so one of them could not survive this. So now you've only got one type. You didn't evolve a better dog. What you just did is what we observe every day. We observe we're losing things.
Okay.
So, yeah, go ahead.
No, I was just trying to think that you're making a point there, because it's like the thing, if a fish suddenly gets legs and starts going onto land, you've got the problem that the transition period, it wouldn't be the fittest, whilst it tries to grow some legs, it would be really slow in the water and probably be eaten by bigger fish, because it's not fit before it can go to land. So I can see that the transition periods between what they claim is happening between species, where the transition goes from one species to another, allegedly, that you would have a big problem, because you get very unfit creatures in the intermediate process from one to the other, which would kind of rule it out, this concept.
The more that one studies sciences, and this is with respect to any field, whether you're dealing with the fossil record, the geology of the planet, most certainly if you're studying genetics, any of these fields of study, the more that you study and research these, the less comfortable you're going to progressively become with the concept in its entirety of evolution. Since 1859, okay, and this is about 100 years ago now, there's quite a few things that we've learned in science developments. For example, the laws of thermodynamics. These ones are, common basic ones that are generally argued against evolution. But let me state what those are. The first law of thermodynamics is telling you that energy can never be created or destroyed. Now, this doesn't have an impact per se on the Darwinian evolution, but it does have an impact on the origin of all of it, the universe itself. It begs the mystery, where did this come from? So that law in and of itself is going to injure you on the belief in the Big Bang. It leaves us of a mystery of the origin. The second law of thermodynamics, and notice the word law in front of these. Okay. These are things that we observe, is the one that's going to hurt evolution, right? This is commonly termed as entropy, the second law of thermodynamics. So, and this is just a basic observable thing. On a day-to-day basis, we observe that organized things, organized systems, tend to deteriorate to chaos over time. So the more time that you have, that the less order that you're going to get in anything. A common example of this is that we're losing things, like I was just going through a moment ago on your bald dog and your hairy dog. We're losing anywhere between 1,000 and 10,000 different species of animal on this planet every single year. And this depends on whose numbers you're listening to. But there is no one out there that is not going to argue that we are losing species, not gaining them. And we've known that for a long time now. Now, we may occasionally discover something we didn't know existed. We may discover a new insect, but this is not a new insect has become. What this is we found something in a jungle somewhere, whatever we didn't know existed. We observe species going away. On the genetic level, this only gets worse.
Okay.
Well, when you're dealing with DNA, for example, we can observe that the DNA is deteriorating over even short spans of time, like the last 20 years that we've really been looking at it on, in single-celled bacteria and viruses. In every organism on this planet, human beings, imagine it like this. If you've got a copy of something and you make a copy of a copy of a copy, so you're losing little bits of information each time you do this. So it's not becoming a better organism, it's actually deteriorating. What I'm telling you is this: we are observably weakening from one generation to the next. And this applies. Now, the stuff is built tough. DNA is a tough stuff. So, these changes are not dramatic from one to the next. We're like little Titanics. This place is well built. But it is deteriorating. It is slowly deteriorating. The next question for evolution that comes into play is that you really are when you're dealing with DNA, you're dealing with programming code. For a program to exist, when you've got a piece of code, whether it be on your computer screen, that coding has to be complete. If it's incomplete at its start, there is no program. So whether you're opening something as simple as a solitaire game on Windows to play for a minute, all of the coding has to be in there. And that coding's not random, not even for something as simple as a game of solitaire. That coding is specific to what the program is. And so when you're dealing with DNA, the odds, and these are the lowball numbers, by the way. On all of my stuff, on videos and such that I put forth, I generally go with the low numbers so that there's no argument about it. But the odds of one strand of DNA are 1 in 48, 1 in 48 with 48 zeros behind it. So that would be 1 in 48 octillion to 1.
Okay.
And for those odds, you would need the parts of the DNA strand to start with all together and shaking around. So if you had the parts, if you had the proteins and the amino acids all together and you were shaking them around, your odds of getting one strand of programming code are 1 in 48 octillion.
Mm-hmm.
Now, that programming code has got to be specifically designed to work with the biological organism, or one single cell. Now, the odds of one cell are 10 to the 39,970 to 1. The software has to work with the biological hardware and vice versa. Wouldn't it be awful if something beat those odds and the software did not match up with the hardware? Now, you need 4 trillion of these to all coordinate. Notice I said the word coordinate. So at bare minimum, even if someone were to believe in evolution, you would at bare minimum need coordinated accidents that produce 0 junk code. There is no junk code in that programming code for DNA. So, yes, in my opinion, these are awfully unusual accidents that we're talking about.
I think I like the idea with the programming code and writing a computer program. And I think a lot of listeners may be able to relate to that. So if you sit down on a computer and you just type in a lot of ones and zeros, and you expect it to produce a game like Solitaire or some software like a Word package or Excel or something, it just wouldn't work, would it? It is just... and the odds are a lot less to I would imagine, to try and create a working program. But unless there's intelligent design behind the program, you don't get anything coming out of it. So so at bare minimum, I think it's safe to say there has to be intelligent design to make DNA work. Is this right?
Well, it's not random. The coding is precise and it's opening up. So there's no randomness in the digital coding, which is the DNA. There's no randomness in the cells, which that DNA software is running inside of. And mind you, each one of these in its inner world is more sophisticated in its inner world than every single automated factory on the face of the planet Earth combined into one small space. So small that we can barely see it with our largest microscopes. That's one cell. Now, there's no spare parts or randomness in the entire functional systems of the organs. Every organ in your body, a listener on the other side of the screen, or in the bodies of the animals here, everything from the smallest little bug to the largest buffalo to the birds in the sky, every little organ inside their body is specifically crafted for their body. Everything from the little size of their hearts to the hollowness of the bones in their wings to whatever little parts they have are designed for them. So these cellular factories have to make up those precision organs, which are all going to work together in a precision symbiotic system of the entirety of the organism itself. And mind you, there is no animal on this planet Earth that has spare mutating parts. They all have exactly the parts that they need
to survive.
So if these are random accidents, these are miraculous random accidents.
Okay, I mean, there's also a problem with the transition between species. I mean, evolutionists, they try to make us believe, there's all this time, and we've got the method of survival of the fittest to try and create some, higher level species. But we've got a problem because we cannot find any evidence of transition between species. Is this right?
Well, no, there's not even evidence of transition of species. In fact, there's the reverse of evidence of transition of species. They've been doing fruit fly experiments for at least the last 100 years. The idea behind this.
Drosophila.
They're inexpensive, and I know this is a common thing that folks that study the topics know about, but a lot of folks probably may not know about them. The fruit fly experiments, these are something that many universities have done, ongoing now for 100 years in some spots. Tens, if not hundreds of thousands of generations of fruit flies. So they use the fruit flies because, number one, they're inexpensive, but also, number two, they have short little lifespans. So the idea here is you encourage these fruit flies to mutate, and you have a bunch of generations of them, so you're trying to force evolution. until to date, every mutation, well, the fruit flies refuse to become anything other than fruit flies. In fact, this has never produced even as much as a new enzyme in a fruit fly. Most all mutations are going to be degenerative because the body of that creature is the way that it needs to be. If you do something to interfere with that or to mutate the animal or you hit it with see, these things are not going to help it. They're probably going to injure it. And taking that one step further, for the last 20 years, actually longer at this point, we've been doing these same type of experiments. Alan Linton and his team have been, and these guys are trying to prove evolution. These aren't creation guys. These are the guys that are hoping dearly that it'll work. What they'll do is take single-celled bacteria, right? They'll culture the bacteria, and they're doing all sorts of things to encourage the bacteria to mutate. So you're dealing with single-celled organisms, organisms that produce a new generation every 30 minutes. And in 20 years of doing this, and Lord knows how many generations we're talking about, millions probably in this case, they're degenerative. The mutations are degenerative. A good case scenario is that they can actually survive whatever the mutation is. That's a thumbs up case. You're dealing with biological machines, and exposing them to mutanogens does not make them construct better parts. You need these new parts to come from somewhere. And random accidents, when you've got a cell, which is like, imagine a cell being like a computerized factory. And now what you're doing is you're adding mutations. So you've got this precision factory, and you're doing things to interfere with those electrical factory parts. That's not going to produce a benefit. In fact, it could destroy it.
I think it's it's interesting and it's exciting at the same time to see that that evolution simply doesn't work. Even when you look at experiments which have been going on for decades, and you're looking at hundreds, thousands of generations, and all you get is just like a degradation rather than an amplification. I mean, they say things like. For example, as far as some cells are concerned, or some diseases are concerned, that they become resistant to medication, like penicillin and other things. But we're back to the point. I mean, there might be some mutation which makes a bacteria resilient, but on the other side, it doesn't go from a single celler to a double celler or anything like that. So I mean, it's never been proven that a species is jumped over and an organism becomes something else other than just, I think the term is adaptation. They've proven adaptation, but they haven't proven evolution as such. Yeah. I think last time we talked about the butterfly experiment. Do you know about that? The moth in.
No, I'm not familiar with these. Tell me about it.
No, I was just. This was what I had to learn when I was doing my A levels, and we had to study evolution, genetics, and all the rest of it. And the big example they used for the evolution was some moth which was here in England, and a recessive gene turned the moth into, made the wings go black. So instead of the moth having naturally white wings. The recessive gene, would turn it black. So 1 in 10 moth or something would have black wings. And what was happening is because Industrial Revolution, all the buildings, they started sooting up and they turned black. So the predator of the moth was picking out the white ones quite easily because the contrast between the black background was quite high. And so the black-colored wings of the moth survived, and the white-colored ones were eaten up, and so suddenly the moth turned from white to black. Then Industrial Revolution was over, the walls were white again, and the whole process reversed. And suddenly the white moth returned, and the black moth disappeared, or the black-winged moth. So the example they were using it for was just to prove evolution. From a creationist point of view, I would say it's not evolution. All it is just adaptation, and it's adapting to different environments in order to survive. Yeah.
Let me address that real quick, because it's it's one that comes up in questions a lot, where where you'll hear it said, well, this bacteria got immune to a penicillin, or a bacteria got immune to something. We've understood Mendel's laws of genetics. Mendel was a contemporary of Charles Darwin. So all animals, and this applies to even your single-celled bacteria, it also applies to your moths. So when you're dealing with horses, per se, you have all of these variations of horses. And just like a piece of software is compatible with certain types of software, but not others. See, the horse, you can have a spotted horse, you can have different types of horses, and they're compatible with each other. Same thing with dogs, same thing with foxes, and same thing with viruses. They do lateral gene transfers. So this is their mechanism, but all of these are restricted. Dogs, for example, are not compatible with turtles. So these have boundaries within them. So in the moth example there, the presumption is that you've got you've got the ability within the moth already inside the coding. You've got the ability for white moths, and you've got the ability for black moths. They're both moths. The moth will never evolve to become a horse. It's just got moth code, but it's got you could view these like little applications within the code, right? So it could be white, could be black, could have spots, could not have spots. So if you've got the birds picking off the white ones, right, and the only ones that are breeding now are the black ones, and the white ones are very few in supply, right? Then you've got a population of black ones. On the issue, but they're not. Where I'm going with that is this: is that you're not getting a new creature. You're not getting something that's not already in the code. Just like with the bald dog and the hairy dog, they're both dogs, and one of them, the hairy one, becoming predominant, right, is because the white one couldn't make it.
Okay.
Right?
Yeah.
Now, when you're dealing with something on the cellular level, and this is a question that gets asked a lot on the bacteria, something gets an immunity to something. Now, there's a variety of reasons that can happen, but I happen to know quite a little bit about virology. It's fascinating to me. Now, what can occur with these is that if you have the penicillin coming in, or whatever your thing is, right? And so some of these cells have got binding sites it can attach to, all right? And so the penicillin will come in and it will be effective. It'll be able to get in there and do its job. Now, if you're missing the code from some of those cells, just like your moths, right? Let's say it cannot attach the binding site. So your cell has actually lost information. But that information that it has lost has actually made it where it's now immune, because this thing can't grab hold of it. You see where I'm going with that?
Okay, yeah.
Now you're getting a reproduction of things that are immune. Now you're getting a population that's going to reproduce that's immune. Let me put it another way. Let's say you were in Nazi Germany, and an order was given to arrest everyone. You have to go handcuff them, and then you're going to execute them. Okay? Now let's say you didn't have any arms. So they decide, so they're not going to put handcuffs on you. We're just going to pass that guy by. He's got no arms, right? So in that case, you were favored, right? So in that case, you survived over the other ones that they could bind with the handcuffs. There's no example of even a bacteria changing from one to another, and further than that, on the inside of even single-celled organisms, there is no example of a single-celled organism even developing as much as a new function.
Mm-hmm.
Those cells are comprised of little bitty machines that are zipping back and forth. So for it to get a new function, it would somehow have to develop new machinery that did something on the inside of it. So you bottom line, I mean, you can observe decay in everything here. And the question that's the fundamental argument, the difference between evolution and creation is, did this randomly and accidentally occur, or does that precision information have a source? And if in fact the evolution occurred, my first question would be, where is a practical example of it?
And there isn't any.
No, there's not an example of something gaining complexity, which is what you would need. And you would need this to such a degree that somehow from inorganic material, literally rocks, whether you want to view it's a cosmic soup or a volcano, by some mechanism, inorganic material has to take the shape of literal programming code, turn into biological machinery, and then advance from a single-celled organism to every animal that you see on this planet, as well as us. And there's, when you really begin to break that down, at bare minimum, even your hardest core atheist would have to admit this is a heck of a stretch. Right? Particularly when we're fighting with, you can't get a cell to develop one new function. Going from a cell, even if you started with one, and the odds of that are 10 to the 39,970 to 1, even if you start with that cell, now you've got to get a human out of that. And where's the science for it?
It's just nothing there. Just nothing at all. You once made an interesting point, sort of, I remember talking to you about it. When you start off with evolution, you've got so many interdependencies within creation as it stands now that that it's almost impossible to sort of explain how everything fits together. So, for example, plants need carbon dioxide, somebody needs to produce carbon dioxide. So, can you talk a little bit about that? When you look at creation, the 6-day thing.
On one hand of the fence, and I used to feel this way as well. So I'm in the ballpark of that, because on one hand of the fence, there's a part of the mind, I guess, that thinks themselves, my gosh, this has got to happen. There's just no way that this can't happen in an enormous amount of time. For some reason, that makes sense to the mind. But on the other end of the fence, when I really look at that, the evolution at bare minimum could not occur in a piecemeal fashion, which is what is suggested by it. And the reason why that is because most everything here is in what's called symbiotic systems. There's symbiotic relationships. And this applies, as Michael is mentioning, the simple example of this is that we exhale carbon dioxide, and the trees are, churning this into, they're spitting back the oxygen that we need in return. But this isn't onesies and twosies of examples. This is literally, if you were to pick through the things that it required just for one single cell to survive in this place, it would be an uncountable number of things. I don't even know if you could find them all. And you would probably ultimately come to the conclusion that it required all of the systems or a significant portion of those systems. So you don't just need one thing that's beating the odds repeatedly. See, that thing is dependent on other things. So you need other things beating those exact same odds simultaneously for this place to exist. There's no chicken before the egg.
It's interesting.
Yeah. And that exists in the DNA, for example.
Mm.
You need a DNA strand. A DNA strand is comprised of proteins, which are in specific configuration. So this is a three-dimensional piece of digital programming code. It has to be three-dimensional because it's building three-dimensional biological organisms from scratch. It also has to have redundant error correction built in to make sure this comes out right. It's no trite piece of business. If you took every piece of programming code we've got, combined them into one, you are light years away from one strand of DNA. You're talking about biological software that's beyond imagination. But it's not just one piece that you need. To get that DNA strand, you've got to have a DNA strand to give the proteins the directions to build the other DNA strand. There is no chicken before the egg.
Yeah, it's interesting. We've got about 15 minutes left. Let's sort of move the conversation a little bit to a different angle. I mean, when I look around, I mean, recently I went on a seminar. It's to do with computer courses, so I was together with a lot of people, and I told one guy, he was actually a biologist, and his specialism was evolution. So I just made a point and I said, look, I don't believe in that. I believe in creation, and I believe that man is created, and that, you know, whatever we see is all created by God. And he just thought I was a complete idiot, and suddenly we had this big discussion going between all the course participants, and it felt like they were all against me. And it was quite interesting to see as well. A couple of arguments, you know, to try and shatter some of the evolutionist ideas. But what's it like in America? I mean, there are a lot more creationists in America, but is there still sort of the majority being totally convinced that evolution is the way we go? And why do you think, what is the big picture behind it to indoctrinate people with this idea and concept of evolution? I mean, if you go back 200 years, even 100 years, the majority of people believed in creation and believed that God had created them.
These folks can't find God for the same reason that a crook can't find a cop. They're running from the, but because if there's a God, that means somebody is in charge and not them. That's why they're looking for a naturalistic explanation for things that, in my opinion, transcend a naturalistic cause. Yeah. And that's why they find these errors when they're that's why they find that. That's why you're finding guesses that are built on guesses that are built on guesses, and pretty soon you're way out here in ball field A because they desperately need for it to be true. And so, you know, what I have is not, you know, I'm a little different than the other guys that talk about this evolution creation stuff, and the way that I really am interested in getting in back and forth kind of, you know, these fist fights with them, as much as I have some basic questions. I mean, you really are dealing with programming code. So what was zero? It's got zero junk code in it. So what is the source of that? Everything here is a causality, a cause and effect. So what is the cause? Where do we get the naturalistic cause for digital programming code for every biological? And this extends to the universe as well. The universe is not a random piece of business. The universe is described to us as being a product of a random explosion. And we'll talk about the Big Bang another time. But when you look up there at those planets in our solar system, you are not looking at a random operation. And this is critical because the irreducible complexity of this entire situation here is from bottom to top. If the universe was not the way that it is, you and I would not be talking. We know, since Einstein, we've known about the cosmological constant. There are thousands of fine-tuned, the universe is a fine-tuned piece of business. It's also finite. That's an enormously powerful piece of knowledge right there. And the smallest particles of this place, I'm quoting Max Planck, the father of quantum physics, who stated there's but one question left, and that is, what is the mind behind the matrix of all matter? There are many, many quotes by him on that subject. This only gets worse when you go from the DNA strands, which are programming code that build biological organisms, and then you look in the arenas of consciousness. You're going to have a lot of trouble as an evolutionist finding somebody that's going to give you a natural cause. So you not only need the rocks to somehow produce inorganic material, has to produce biological machinery that is beyond belief, is precision, and is all symbiotic. But now you need it to somehow develop consciousness, which none of us understand. And then the fabric matrix of the place that we're in, that's not random either. By any mathematical construct, this entire place, reality itself, should be nothing more than a superposition of randomness with nothing definite ever happening. Yet it's not. It's completely the reverse of that. And that's what the physicists are saying when they call this a holographic universe, or you hear terms that that sound sort of interesting, like reality is a digital simulation. They're saying these things because we're living in an age where we can look at the particles and they are not random. Thus bringing me right back to Max Planck's words. What is the intelligent mind behind the matrix of this matter? And should it be surprising that we find that inside that construct, the living organisms are made of what's comprised of programming code? Should it be surprising that we find in that construct that it's not a bunch of rocks smashing into each other? We're in a precision environment. And if it weren't the way that it is, we wouldn't be having this, we wouldn't be here, we wouldn't exist.
Yeah, it's like this thing, if we were a few degrees a bit further away from the sun, it wouldn't work. If we were a little bit closer to the sun, it wouldn't work either. I've heard some stuff, even the moon. If the moon would be just a little bit closer, a little bit further away, life just wouldn't be possible the way we've got it. And then some interesting facts like the moon and the sun, as seen from the Earth, are in identical size. So it's like the moon, if you've got the, what's it called? When the moon places itself in front of the sun, it's an identical slice. So the sun is totally covered. So there's some interesting facts as well when you look at that and you think, surely this can't be accident. There's intelligent design behind it, for certain.
It's
solar eclipse. That was the word I was looking for. If there's a solar eclipse, the moon and the sun are the identical size, and so the moon just covers the sun exactly. So it's not smaller, not bigger, but it's just exactly. But it's fascinating when you look at that. But I think it's like you say, pretty much anything. You open your eyes and you look at ourselves. You look at creation. You look at a plant. Everything just points to God and saying that there is a creator out there who has done all this. And you look into the cosmos, into the solar system, and it's the same thing. You can just see there's so much order, and also the information we have today. Like Venus. Being the same size as the Earth, pretty much the same size. Life impossible because it's just too hot. Mars, impossible to live there. It's too cold. And yet they're pretty close in orbit to the sun. But it's interesting. So you just know, yes, somebody's placed the Earth just where the Earth is. And if it were a bit further away or a bit closer, it just wouldn't work. Fascinating stuff. How can we refute an evolutionist? Few words, just in a few sentences? What would shake them? Your main point is intelligent design, the computer code,
Well,
the gene code.
yeah, I think the DNA is in my opinion, is the simplest way to kill it, because it's just
too amazing.
You need programming code to come out of rocks somehow. But I mean, the list of problems is the ones you could go over with them. Number one, how does entropy, the second law of thermodynamics, how do you get around that? Number two, the biogenesis, life only comes from other life. We've known for a long time now spontaneous generation does not occur. Mendel's laws of genetics. Notice the word law behind all of these things I'm listing off. These are day-to-day sciences that we use, and evolution conflicts with every single one of them. Mendel's laws of genetics. The animals stay within their kinds. Horses breed other horses. They can have variations of horses, but they cannot give birth to turtles. Not even in a million years. The coding is just like a piece of programming code. If the program code is not there to build a turtle, there is no turtle. It's just, there's no magic here. It's either in the code or it's not. So all of the animals are in their species kinds. Irreducible complexity. The parts of those animals are irreducibly complex. Well, especially on the cellular level. I mean, you start removing parts from the animal, you're injuring its ability to live. It has no spare mutating parts. All of its parts, though you could remove a leg and the animal still can live, that animal really does need its legs, and it really does need it's got all of the functional parts that it needs. The law of information systems. Information always has a source, right? So when you're looking at digital programming code, the question is, where does that coding come from? The fossil record. We've been studying fossils for a long time now. We don't have, there are no transitional fossils. There's none. You've got fossil. You'd have to have transitional fossils for every creature on Earth. This isn't just between the monkeys and the people. A woodpecker has a skull where its tongue goes around the back of the skull, goes through sort of a thing inside the nostril cavity, and comes out through the mouth. Where's the transitional fossil leading to that? Or any bird, for that matter. Where's the transitional fossils that would become a There's none. We've got piles of fossils. Dog fossils, always horses, and et cetera, et cetera, et cetera. So if this science-defying activity were occurring, where is the evidence for it? You would think that it would be readily available in the fossil record. Genetic complexity, which is really what it fundamentally boils down to. All of these answers I'm going to give you, and all of their affiliated laws, all have to do with the precision and complexity of the place.
Okay, we've got about 2 minutes left. Trey, you've got a website, you've got a project you're working on. Tell me about your project, God in a nutshell.
The theory of everything is the last video that I put up. I run something called the God in a Nutshell Project. And what this is a collection of primarily short documentaries on different subjects. The last one out is my personal favorite. It'll take you through everything from Noah's Ark to the beliefs of the Babylonians to the genetics to everything from the cells to the stars. And it is a very easy journey through all of these topics. Things about 3 hours long. You can watch it in parts if you want. You can also watch it for free. That was very important to me, to make it available where you don't have to purchase it. You can get a higher quality copy if you like. But it's up there for free so that you can enjoy it. Just to have it. And its title is The Theory of Everything.
Okay, so the way to find it is YouTube, yeah, that's right, and then Trey Smith, or Trey Smith. Trey
Smith, or you can just type in God in a Nutshell into your search browser, godinanutshell.com, and you're going to find the movie for free online, the DVDs, and you'll find the other videos that I've made on there as well. So if there's some other topic you like, then you can watch that one too.
Okay, right. Trey, thank you very much. That's very kind of you. Spend this time with us here on the radio station. There's more to come from Trey. There are a couple of other subjects we need to chew through. You already mentioned Noah and the Ark, and there's lots of stuff there. What other subjects are you dealing with? You did the Babylonians, the Egyptians.
The Book of Enoch is the most popular one. Of the videos that I put together, the one that people seem to enjoy or go to the most is on the Book of Enoch, and that was a text that's claimed to be actually written by Enoch, the seventh from Adam, the great-grandfather of Noah. So I do a breakdown of what that text says in a nutshell.
Okay.
And it's for you to decide on the other side of the screen if it's authentic or not. I believe there's significant reason to believe that it is, but I lay that in your hands.
Okay. Right, we're out of time. Trey, thank you very much. Okay. Next week, same time for our listeners to tune in, and you can hear more from Trey Smith. Or alternately, just go to the website God in a Nutshell, or just Google Trey Smith and go to YouTube, and you can find him there. Okay, Trey, thank you very much.